My name's Jerry Nixon. I'm on the SQL Server team at Microsoft. That's the reason I was asking. And we have quite a cool thing to show you here. And it might make more sense. Well, let me start by saying I live in America. I live in Colorado. That's where Colorado is. Let's move on. Okay. SQL Server is so loaded with features, so you're absolutely right about that. And but we are only going to be talking about the SQL MCP Server and Data API Builder. And the reason we're talking about two things instead of one is because they are the same thing with two names. And so it's very easy to talk about both of them, and I'll explain to you here in just a second what I mean. But this is sort of the current landscape of things that are available inside of SQL. It's pretty stunning. Like, we have turned our attention. We have served the DBA for so long that the DBA is well served. That's the best way to say it. Like, it is an incredible experience if you're a DBA of the things that you can do around high availability and all the other things. But we kind of underserved the developer for quite a long time. In the last 4 years, we've really changed our direction and our cadence. And so it's been great. And I'll explain this in just a second. Let's talk architecturally. If you are a software developer today, then you probably are writing an application that has 3 tiers. It's very normal to write that. And the reason you would do that is because you don't want your application to speak directly to your database. Even though an application can certainly speak directly to its database, that is not the best reason, or the best idea. And the reason for that is that the application itself doesn't have the flexibility to make significant changes without requiring the database then to change too. So if I keep the surface of the API the same by just changing it mechanically behind the scenes, I can let the application stay even though I changed the database behind it. And I can do the opposite. If I make it so that the surface changes to allow the application to do whatever it wants to, then the database can stay the same and nobody knows the difference. And so you have this abstraction layer. We all know why we have 3 tiers. I just want to explain it for a second. Now I want to say that this tier by itself is a significant problem and probably the worst thing that you can add to any code base. And the reason is the way you build an API layer is very, very frustratingly simple. All you do is create in C# you would create like a minimal API with a couple of entity framework sort of things going on. And it's just a CRUD op, right, where you just have your get, your put, your delete. And all the operations happen there, and you do it every project exactly the same. Which means when you go from project 1 to project 2, you just copy all of the code from project 1 into project 2, change the name of your methods, change the name of your classes, and everything still works perfect because you did it right the first time. That's copy-paste inheritance, and it introduces a lot of problems because things change from year to year, as you know. And also, the mistake that you got away with because the previous application didn't do it, the new application now has that problem. The other issue is API code in general, because CRUD code is boring, and we all hate it. And so we get done with it as quickly as we can, and we move on. But we still have to have the same unit tests against it, so we just copy our unit tests over from our previous project. We still have to implement it into and automate it into our CI/CD pipeline, which is fine as well. But hopefully you're getting the idea that these CRUD APIs, which do nothing special, introduce an opportunity for error and bloat your overall application for something that is incredibly trivial. And so that's sort of where we're headed with this. That you don't want, I think you should be able to take this entire fourth third of your code base and just delete it. It's probably a useless piece, a maintenance piece that you shouldn't have, and it also introduces potential problems that you shouldn't have to deal with. So you have 3 parts to your code. One of them is the API, still a good architecture, just not right to have it as source code inside your code base. How do we deal with it? Well, that's the reason we're talking about a data API builder. The easiest is you're going to have some sort of data API. So some sort of API is going to exist here, and some sort of data API is going to exist here, and then we'll replace this with data API builder. Sorry, the animation did double. And the upside is this becomes a tiny, tiny shim. You may not even have business logic in your API. You can delete that as well. If all it is CRUD operations, it's your client talking directly to Data API Builder. So let me start by saying a couple of things just because these are the immediate questions people have. I've been talking about Data API Builder for 2 years. So for 3 years, but it's been GA for 2 years. Data API Builder is written by Microsoft, maintained by Microsoft, written specifically by the SQL team. It supports SQL. It's every single flavor of SQL down to 2016 actually. And it also supports Postgres. It also supports MySQL and Cosmos DB, a NoSQL database. That's right here. It's open source and free. There's no license. It doesn't have to be run. It does run in Azure. It doesn't have to be run in Azure. You can run it in AWS. You can run it on-prem if you want. It's delivered in a container. It's not code generation, nothing like that. It just sits there in a container, and you have a config file that you give it that's written in JSON that anybody can write that basically says this is the connection string to my database. And the end, it can automatically identify all the components of your database, or you can configure what is and isn't exposed. So I just want to give the high level and then talk about the details. The reason this matters is because this scales like crazy. The largest data application at Microsoft, also the largest data company in the world, is Microsoft Fabric. Microsoft Fabric APIs are run on Data API Builder. So it's not a question of it can scale, not a question of whether or not it's secure, and it's not a question of what the license costs because we give it to you for free. That's why it's fun to talk about. And now I know I'm saying Data API Builder over and over again, and we're about to get to SQL MCP Server. Okay, when I add Data API Builder to the solution, and I do or don't delete my business logic, then I get REST APIs. All of you know what REST APIs are, right? /API/ whatever. I also get GraphQL. And so let me show you something real quick that is going to, it'll either dazzle you or bore you. We'll see. So I have a database out there right now, and let me just show you real quick. It is a simple actors database. This has all the Star Trek actors, and it has all the characters here. And I'm just, let me go ahead and run it. And did I talk long enough for it to go to sleep? All right, we'll come back to it in just a second. Let that refresh, and then I'll come right back. I just wanted to kind of show you it working before we moved on, but let me move on for a second anyway. Oh, no, that's what I wanted to show. So you have REST APIs, but you also have GraphQL. So GraphQL doesn't fit in a little circle. It is GraphQL. GraphQL is a language, not a technology. It is a language to query a schema. And what happens is the schema from your database is then expressed into Data API Builder. And whenever you want to interact with your data, you never write T-SQL. You only write GraphQL queries. And those are extremely simplistic. All of the join syntax, all of the having syntax, all of the group by syntax, everything else is hidden away and wrapped inside of the schema and automatically generated for you. You only write this very simple sort of nested query. And it is also limited to only what you expose. So it's different than saying, just write a query against my database. Well, show me all your tables. That's not what you want. You want to be able to say, let's write a query against only the tables and objects that I want to expose. We'll turn those into an abstracted subschema, and then I can write GraphQL against that. That means that your engineering team can be super duper, and they can write all kinds of T-SQL, or and go directly against the database, or they can be just a normal engineering team that maybe doesn't have the top T-SQL skills, and they can still be awesome because all they need is JSON and HTTP. That is incredible. So REST is JSON and HTTP. GraphQL is JSON and HTTP because the GraphQL query language is basically a variant of JSON. And so it makes it so that the barrier of entry has dropped to the floor, and it's really nice. That means also that I can introduce Data API Builder as my API layer in front of my database, and I already have all of the security figured out. I already have all of the caching, all of the Redis support figured out. I have all of the container work figured out. I have all the pagination of data figured out. I have all the pre-built queries and automatic query generation, which is inside of Data API Builder, figured out. All the things that if you had enough time and budget, you would do it yourself. We have already done it for you, given it to you for free, and given you the source code to review for yourself so you can see that it's not anything exotic. And now you have REST, and now you have GraphQL. So if your application wants to get the entire thing figured out, like you're like, I'm going to do everything in REST, we don't do GraphQL. I'm like, that's totally cool. You can enable GraphQL also, and you can dabble with it, or you can just turn it off. So it's not one or the other, you can have them both, or the other way around too. All right, now, if you have an agent instead, totally new world, now we have an agent doing work for us. If you have an agent instead, now your application talks to an AI agent that's out there, which is basically just a front end to a model, right? We just call it an agent, but we could call it a model and still be right. And so this agent is interacting with some model that's hidden in the dark, and it needs to talk to your database. That's normal, right? We want to make it so that I can say to my agent, how many customers do I have? How many customers in Ohio do I have? How many customers that spend more than $1,000, whatever it is. You just want to be able to ask those really complex questions, which means you want the agent to be able to talk to your database. Maybe you also want the agent to be able to do mutations. So that means I would say to my agent, change the last contacted date on this customer to today, right? Something like that. Change the number of employees to 5 instead of 10 or whatever. Things that I might want it to do to the database. Add a new customer, add a new product, add a new CRM entry, whatever it is. This is the problem right here. An agent cannot speak to a database. They cannot. If in your mind you're like, agents will talk to databases, you're right, they can, but not like this. They can't. You can't just say, here's my connection string, and it'll start to work. If you give an agent a connection string, let's say you're in Visual Studio Code. If you give an agent a connection string, now I'm going to wake up my SQL Server, which probably is also going to sleep. Okay, great. If you give an agent your connection string, it won't know what to do with it. The best it can do in Visual Studio Code is to go to the terminal and run something like SQL command at the terminal and connect to your database by giving the connection string, which means there's something right here that you need. And what we need to solve is not inside Visual Studio Code, because that's silly. That's for us. When we talk about customers interacting with your production database, we need something here that can run in the cloud, in the service, something that can make it so that it is completely headless and transparent, but still compliant to what an agent needs. And that's what an MCP server is. So MCP servers are stupid. If you've never written one, they're like 4 lines and you're done. It's the craziest thing how simplistic they are. And so if you're writing a minimal API today, and it was a CRUD API, let's say it was like just a read API, all you have to do is decorate it, right? Just to put a different attribute on top of the method, and it will emit the pieces that you need through ASP.NET code just because of the library you have. It's very, very simplistic because MCP is just the standard. It's just the way that the surface needs to look so an agent will see it. That's because REST is a free-for-all. We don't know how you're going to implement REST, but we do know how you're going to implement MCP because it's a standard, right? That's the reason we had to invent it. So right here, all we have to do is introduce something that is different, and that's why I'm talking to you, right? So we definitely can't just do it with nothing, but I can do it with Data API Builder. Now we are in a new world. With your MCP, by the way, we're not trying to introduce new code to your code base. We're trying to remove code from your code base. So you might be tempted to write your own database MCP. You can. That's okay, but the goal is not to do that. The goal instead is to replace it with Data API Builder. And so Data API Builder is this spot. And when we do that, we call it SQL MCP Server. And the reason we call it a SQL MCP Server has totally to do with Google.com. Nobody Googles Data API Builder with MCP support. Everybody Googles SQL MCP Server. So we just gave it 2 names. One engine, 2 names. And we'll talk about how you can do it all at the same time. However, MCP is the 3rd endpoint that the Data API Builder can expose with the same configuration. So you already have that configuration file in place, and we just kind of have it exposed using the same one, which means you can use all 3 at the same time. So just an FYI, MCP enabled Data API Builder. This is a little bit of a source of humor even inside of Microsoft, I'll be honest, because we're like, hey, I'm the PM of Data API Builder, and then they ask if I'm the PM of SQL MCP Server. And it's an honest question because it's difficult. Not a lot of things have 2 unique names like that, but it's one thing with 2 names. Yeah, that's right. All right. If you're building an application or if you're building an agentic solution, either way, it's the same solution at the same time. So inside that JSON configuration file, I would say MCP enabled, Graph enabled, REST enabled, whatever it is. So let me show you that because it's kind of fun to see. And all right, so I have my database running. I just want to make sure everything is running nicely. And let me jump to, here we go. Let me make it bigger so you guys can see it more easily. Let me hide what's here so you don't mess with that. All right, so I have an environment variable, or I have an env file that has environment variables in it, that has my connection string already set up. And it's my Star Trek database, as you can see. I'm going to scroll to the right just as a trust exercise so that you guys can see my password. There it is. All right, so now you know. And but the way env files work, if you're a Node developer, you already know this. If you're a .NET developer, you may not. And that is, you can put the name-value pairs inside of a file like this, and when you run it, it just elevates it into the process-level environment variable. It's really clever and handy, and I wish .NET did it. But if I right-click, because I have an extension installed called the Omnibus extension, OMNIB. So this is the Data API Builder extension itself, and it is loaded with tons of other, and I'll show you right here, tons of other extensions that all come together. So Omnibus just means all the things. And so this is the all the things extension. And so let me close this so you don't think about it too much. But if I right-click, I have the option now to say dab init, so initialize dab. So what I'm going to do is I'm going to create just the file that controls Data API Builder. Remember, it's deployed in a container, so I don't actually configure the container, just this one file, and then I give that file to the container. And so I will say dab init here. It finds my Star Trek database, and it runs down here the cross-platform CLI that we have for dab. And so it has created this JSON file. This is the JSON file that controls it, and it's crazy simplistic. Up here is the data source itself. So here's the connection string that's reading from the environment variable. I could have hard-coded it in here if I wanted to, or read from an environment variable. I could also read from Azure Key Vault if I want to. And then this subsection that is appear to that is the runtime that allows me to turn on and off the capabilities of the endpoint, of the API, right? So here, I have REST simply because of this. And I have GraphQL simply because of this. And I have MCP simply because of this. And so if I wanted to mix and match, and I wanted it to not have MCP and not have Graph, or to have MCP but only Graph, whatever I want is up to me. They can all be or none, right? So one doesn't disqualify another. It's really cool. Now down here, I'll skip over the authentication and stuff. Just know it's freaking awesome. We have this entities section, which is the list of all the tables, views, or store procedures that you have in your database. And those are the things that you're going to expose in your endpoint or through your tools, through your MCP tools. And so the easiest way is just to show you how I would add one. So let me just add I'll go to add tables. And the reason I can do that is simply because of that omnibus. And I'll have a list of let's do characters instead of, we'll do both, characters and actors. And so now, these are just the commands that you would normally run. Dab add, and then you add a table. And then dab update, and you can update the definition or the description of the table. And the reason descriptions don't matter when you're in REST, not really. But descriptions really matter when you're in MCP. So if you have an application, talking to your REST endpoint, it doesn't care what the description of the table is because you've written an application hard-coded to that endpoint anyway. You know exactly that it's for customers and because you're going to show it in your customer's field or in your customer's form. In an agent, it does matter because it doesn't have an application. Everything is ad hoc. Everything is dynamic. It doesn't know what you're going to ask. And so it then talks through MCP Server down to the same set of tables. But the MCP server now has all these descriptions to semantically explain to the model, this table is for this column holds this type of data. So if you're going to try and create a query, this is why you would do it, right? And so it's really important to have this semantic description in an MCP server. And obviously we have it, but I just wanted to show you why there were so many things going by because I was adding the configuration or the description for every column. So now, entities is no longer an empty object inside of the configuration file. Now I have the first table, which is actor, which is not that. This is the name of the table, DBO actor. This is the name of the entity or the alias that's inside of my API. The reason that matters is you may not want to expose all of your table names. You may find it that leaking your schema actually reveals too much of your internal systems. So you want to be able to make some changes. So it says actor, but I could easily change it to something else, right? Like literally something else. And if you didn't want to have actor out, it could be worker or it could be employee or whatever it is. Whatever makes sense to you. I could do that with every object, every column, all the way down, including store procedures and parameters inside the store procedures too. So here's my list of fields, whether or not it's the primary key. What the description, the default description, I don't know it, right? This is just a Visual Studio extension, so I just had to say, here's the name and here's the type. But you would come back in and be like, this is very much insufficient. I would call it key or primary key or whatever it is that makes it. This is how I identify the actor. Either one is fine. And then you would come down, and some things are really tricky, right? And whether or not full name includes a space, all the things that you would do to be able to communicate to the model and say, this is not a normal column. I just want you to know how to use it. Okay. Now, all right, now everything is running. And so let me add one more thing. So let me add a relationship. So the relationship between tables can be in your database and then exposed to your API, or it can not be in your database but still exposed to your API. Lots of times we as developers don't have access to the database to be able to make structural changes. You can force a structural change that is, let's call it a pretend change, inside the API itself. So I know that these two objects really are related, but my DBA won't let me change my Salesforce database, so I create that relationship at the API layer. Now that doesn't matter if I'm using REST. REST is one object at a time. But if I'm using GraphQL, it's a big deal, and it's freaking awesome. And so here's character to actor, right? So an actor plays a character, or an actor or a character is played by an actor. And so now let me start it just so you can see what it looks like. So I'll say start. Everything's in the command line. We don't have a UI. It says dab space start, and it just runs it. This is ASP.NET Core behind the scenes, just so you know. You'll never see that. This has no operating system requirement. This has no language requirement. There's no framework to install. This is just a HTTP endpoint that you talk over JSON. That means it works in every possible topology out there, and as long as you have containers. And if you don't have containers, then you can run our cross-platform CLI directly and say dab start in any environment, and then you don't have to run it in a container. So it's every possible that you can imagine. And we'll go through some of the architectures. All right, so it's running. You can see it's localhost 5,000. And obviously, you could change all of those things, but this is the way it works. And I just happen to have localhost 5,000 right here. And so this is the /health endpoint. I know it's kind of hard to see, but just know it's localhost 5,000 /health. This is the health endpoint that allows you to immediately go and see everything and how it's running and how fast everything is working. So if I were just to kind of show you real quick, this is a summary of the configuration. This is the list of all the checks. This first check just tries to open up the database to prove that your connection string works. This is really valuable when you're trying to figure out why production isn't working, right? And so now I know that at least the database is working. Now I can come down here and I can see this is my GraphQL endpoint for character only, and I can see that it ran and that it ran in this case, it ran in 2,000 milliseconds, and I would only allow 1,000 milliseconds. Now this is obviously the SQL Server either went to sleep or something and just woke up, and that caused that delay. If I ran it again, you would have a different response because everything should be more like this, 99 milliseconds. That makes much more sense. And once everything is super fast like this, just think about this JSON is at a URL that you have access to. You could easily just query this and immediately create a report, right? And so I've done this too. Let me show you. I'll show you the report. I could right-click on, well, I'll do it here just because it's part, and I could say health check. It expects it to be at 5,000 /health. It's going to get back the same JSON that I just showed you, and just formats it. Now, wouldn't this be an awesome dashboard for your application, or at least to be snapped into the existing dashboard you already have? So it's nice to be able to do that just as raw data. Now, this isn't really a demo about health. I just wanted you to see that we have it. It's really cool. We have so much. I won't be able to show you about half of the stuff we've got. So this is Swagger. Swagger is built in, so you don't have to have Swagger on the side. There's a mode that you can toggle between production and development. When you toggle to production, obviously Swagger is turned off, right? We would never do that. But it does allow you to see how everything is broken out. So all I said was this is the table. It breaks out the get, put, patch, delete, and all the other things as well. All of the filtering, all of the pagination that's in there, all of the custom predicates are all built in. You don't even have to set them up. You just get them. One of the things is custom predicates is this. We call them database policies. And what it allows you to do, if you're a DBA and you're like, this table is very delicate. The data is sensitive. And so I'm going to make it so Jerry can only see Jerry's. And so the way I'm going to do that is through RLS. That's row level security. And what I do, it's complex, but this is what I do. Only when Jerry does a query and his account is doing a query, then I want to make sure that he is that his username matches one of the columns or something along those lines, right? Somehow I'm going to make it so that, and what happens is no matter what I query, that is tagged on to my query automatically by SQL Server. That's the way it works. And so that's row-level security. That's cool. But what happens if you can't make change to the database? Well, now we can take row-level security and push it up to the API, and we can inject the same kind of predicate, exactly the same behavior, but at the API layer, making it so that when Jerry comes in and he tries to access data from the table, it's still limited only to what Jerry can see. So that's pretty cool. All right, that's one more thing to show you. This is Nitro. If you've never seen Nitro, Nitro is the Swagger for GraphQL. So we ship Swagger for all your REST endpoints. This is Nitro, which used to be called Banana Cake Pop. Everything's got a crazy name. And this is how you would interact with GraphQL. So let me go ahead and do that. And then let me just show you kind of how it, wait, let me do a quick refresh now that I restarted it. There we go. And so now, if I were just to, schema unavailable, say it's not true. Hang on just a second. We're going to fix this because it's great. GraphQL. Oh, nope, sorry. Nope. There we go. GraphQL. Okay, now, no, schema is still unavailable. Well, we know the graph is working because it's right there, right? Unless it's lying to me, but it's not lying to me. Still running, still right here. This will take about, I'll give this one try and then we'll move on because there's just too much to tell you about. Just know that graph works, obviously. GraphQL. There we go. Schema unavailable. That is weird, right? That's not the way it's supposed to be. Now the schema is available. Okay, so this tree, let me move my mouse. This tree sort of shows you all the things that were automatically created for you, and this allows me to show you how awesome GraphQL, the query language, is. So I can go into an actor, for example, and I can say, of the items, which is what we call columns, tell me all the names, right? So let's just run that real quick. So two things happened. This is the query itself. This is just the builder. This is the query, right? So it's a query called A, because you can have more than one query in one thing, which is incredible. And so I can say, of the actors, give me just the full name. This is how the results come back. You can see here's the actor. Here are the items. Remember, those are columns. And so full name is William Shatner, Leonard Nimoy, and DeForest Kelley, right? So that's pretty cool. What makes this special and better than REST, I don't want to say better, but different than REST and more powerful than REST in this way, is that I can go in and I have this sub-object here called character, and I can ask for the character name. And basically what I'm saying is there are two tables, they're related together, and I want to do both query. I want to join between them automatically. REST can do this if I point to a view or store procedure that does it, but it can't do it natively. And so now I can go here and run it again. Let me kind of hide some of this stuff so it doesn't have so much noise. Right, and so now here's William Shatner, he plays James Kirk. Here's Leonard Nimoy, he plays Spock, right? So it's really, really cool. I could do the opposite. I could start with character and go in. But that sort of join operation, that is what we rely on Entity Framework to do because we're frustrated with writing joins. Well, the only reason it works in Entity Framework is because we have coded all of the relationships. Here, because it's at the API layer, it is actually derived the relationships either from the database or we've customized them, right? Either option. And applications, they could code it correctly or incorrectly. It doesn't matter. It will always be correct at the API layer. So it allows for far few errors from the application layer when you have it identified or defined here at the API layer. And just to kind of show you what that syntax looks like, because it's curious. Because if you're like me, then you're curious. If I go down to, here we go. So this is inside one of the objects inside that configuration file. And you can see the relationship is just set up here. And it automatically builds itself if you want, or you can do it manually. So pretty cool all the way around. Let's go back to the capabilities of Data API Builder. Any questions, by the way? Yes, sir. Great question. Yeah, I'll talk about it later, but I might not get to it, so I'll talk about it now because you care. So you can anonymously connect to your endpoint. Of course, you want to have that like I am here for a demo, but you would never do it in the real world. You can use intra identity. You can use custom JOTs through Okta or OpenAuth or anything that uses a JOT, which is everything. And if you don't want to make it so that your client passes a token to your API, and then your API passes a token to your database, then you can. We also support OBO, or on behalf of pass-through authentication, which means that your authenticated user here or here passes their token, and we forward their token to the database so that all of your audit logs look as if the user is the one doing the execution. And it also allows you to have all the security on the database if you want. So none or all of it. So everything you can imagine is basically what I mean. Like all of the authentication options that you want to have, we support. The only one that might come up, but it's not really an authentication option, is key-based security. And key-based security is usually at the API management layer, not at our layer. And so to ask for the API to do it is really to ask put it in the wrong place. But other than key-based, which is a common topic, it's every authentication scheme you can imagine. Yeah. Am I answering your question though? Yeah. There sure is. I'm so glad you asked, and I'm sorry I misunderstood. Bless your heart for not interrupting me and let me just go on and on. So you could do that two ways. You can either use the Open API specification, which we support, and so Open API points to the REST endpoints and all of the types. So every single object and all of its subtypes or all of its columns. So, or all of the parameters being passed into that API. So this is the best way if you like Open API. So we support Open API 3, it's great, and so we'll tell you the type of everything. If you don't want to use Open API, or maybe you've disabled disabled REST, then, well, here, I still have it open. And you have GraphQL. Then this tree over here is built from the schema itself. This is what the schema looks like. Let's see if I can pull up an example. They don't give you the raw schema. Well, maybe they do if I click on this. No, they really don't. But just know that all of this information that shows the character, what its native type inside of GraphQL, and then all of the columns, all of the columns, as well as all of the input types, all of their types are exposed. So if you need to know the types, we do it all. And we actually take the unique types in every database and collapse them to a standard set of types as well. So if you have a varchar max and a varchar 10 and an invarchar, we just treat it like a string because in an application it's just a string. And then we do all the validation as you start to do database interactions. Right? So it just takes away all the hard work from your application. And so, but we still pass that on so you can have it, but just letting you know that all of the types, everything is exposed in this way. Until we get to an MCP server. An MCP server doesn't work the same. It doesn't have a type system at all. An MCP server, I'm getting a little bit ahead of myself, but I want to tell you anyway. An MCP server simply has a set of tools. And the way most people talk about MCP is they mistakenly say, yes, sir? Okay, good. They mistakenly say that exact thing. And no, just joking. They may mistakenly say, I need a read, write, or maybe a create, read, update, delete tool for my customers table. And then they're like, I need a create, read, update, delete tool for my products table. And I need a create, read, update, delete tool for my warehouse table. That's 3 tables, 4 tools, that's 12 tools. And Anthropic has already told us that once you get to 20, maybe 40 tables, then you're starting to overwhelm a model with too many tool options. Now imagine you have a database with a reasonable 100 tables. And you want to create CRUD operations against all of those inside an MCP tool so you can enable an agentic solution. Now you're up to 400 tools. You're way past any concept. You've blown the mind of these models. And so that's our serious problem that we have solved. Using SQL MCP Server, we've collapsed everything to 7 tools. The 7 tools that we expose start with a describe entities tool, a tool that says, here's what you can do, here are the things you can CRUD against, basically. And a list of all the tables that are returned to the model paged, making sure that we don't blast you away with 10,000 possible entities, but we allow you to go through. And we also allow the model to trim it down and say, don't tell me anything but the names, and then when I know the name, I can pass that in and get some details. That's really nice. And that's the first tool. The next tool is create, then read, then update, and delete. Each one you pass the name of the entity to it as part of the tool signature, making it so that we have 7 tools if you have the smallest database, and we have 7 tools if you have the largest database, making it so that as you start cranking the wheel and everything gets bigger and bigger, you never get to a place where you start to overwhelm your models. And so this is an MCP solution that is pretty spectacular. I mean, honestly, there are so many things that make this work so well. And since GPT-4.1, multi-step agentic tool use like that, where it says, first I have to do the describe, then I have to do the operation, is not just supported, but it is flawless. It can definitely orchestrate a workflow like that with no problem. If you go back to GPT-4, it didn't know how to do 2 tools back to back and then keep the data between them. But all of that's been resolved in every model since that. I'm using 4 as a time, really, not as a model example. Yes, sir. I forgot that you had a question.
Since you were talking about the tools, if the relationship that you mentioned is not present in the backend config, but the JSON RPC payload that gets sent out by the agent asks for something like that.
Through GraphQL, you doing that? Yeah, so GraphQL is going to validate the query before it tries to execute it. And if I don't have the relationships defined at the API or inferred from the database into the API, then GraphQL will be like, whoa, you're asking for something that can't be done. Yeah. You're wanting dynamic. And so there's a serious issue. Let me do 2 things at once. I can provide, here's my animation. Bloop. All right, so I can provide more than one config file to Data API Builder. If I do that, I can provide access to more than one database at the same time, which means I can write, remember when I said you could write a graph query with 2 queries if you wanted to? You could write 2 queries, single request. It queries both databases, and let's just say this is my SQL in the cloud, this is my SQL on-prem. And now I can have this hybrid on-cloud or cloud and on-prem query, all coming back in a single payload from a single API call. That's pretty awesome. Second thing I can do is, this is SQL Server, let's just say. This is Cosmos DB, a NoSQL database. Now I can do a single query, a double query in a single payload that queries my NoSQL data, queries my relational data, then collapses those down to a single payload and returns back from one API call. Unfreaking believable. How many of these can we've tested? We can't find an upper limit. There is going to be one. If you hit the upper limit, you're probably not using it quite right? I mean, we've gotten big numbers. And so it's fun to try and max things out, but don't be that guy. All right. The next thing is, wait, tell me what you said again. Oh, relationships. So the other issue is we can't relate across databases. Like that think about the memory that it would take to do that. So if I want to query this database and I want to query that database, but I want to collapse or combine those into a single payload, no problem. But if I want to take this data and I want to then join over here and I want to create a relationship between them, it is not impossible. We are all smart engineers. I could write a tool that does that. It would just require an unbelievable amount of RAM, and it would also require an unbelievable amount of time, because I don't know how these joins are all going to play out in the end, so I have to bring a lot of data into memory, and that's monstrous. So there are tools out there that can do this. They are not an API tool. They are a back-end Microsoft Fabric tool. It's much more, this is a big problem to solve that has nothing to do with your API. So if you do need to query across multiple data sources, just use a different tool, right? Or join across this, just use a different tool. This allows you to query across, which is pretty cool. Pretty cool. All right. A couple of things to just remind you. This is open source and free. This is built and maintained by us. We use it ourselves. That's why we like it so much, but we give it to you for free. You can use it in AWS. You can use it wherever you want. And more importantly, though, it is the democratizer of data access. You no longer need to write SQL, and your DBAs are happy about that because they want a reliable, deterministic SQL. And they don't want all the random stuff that we end up writing inside of Entity Framework or in Dapper or anywhere else. They want to know what's coming, and they want to know that you are constrained to only these things. The nice thing is, if you use Data API Builder, only these things turns out to be a freaking lot. So you can do all of the things that you probably want to do without having to introduce a store procedure or something like that. You can still have the same sort of reliable determinism on your SQL. And it's the brand new developer that you just hired who only knows JSON and HTTP, and they're doing the coolest things. I mean, it's really, really neat. And you don't have to worry about them breaking your database or doing all these wild things. It's already available through the API. That's a huge value. By the way, and you've deleted a huge ton of code and simplified your CI/CD pipeline at the same time. I'm not even close to done. Don't even feel like you are ready. Okay, so Mercedes, this is just a 3 thing. It's not Mercedes. So here's the main authentication, right? So we can use any OAuth. Oh, that should say OAuth. Any OAuth, anonymous, of course, and then on behalf of is that pass-through, and we'll talk just a minute more about that in a sec. We have all 3 at the same time, MCP, REST, and that's the reason you can search Data API Builder and find MCP, and it's the reason you can search SQL MCP Server and find REST, right? Because it's the same tool that does all 3, which is really cool. And then from a data sources point of view, SQL and NoSQL are hybrid, all at the same time. And I have a list, and it's kind of mind-numbing when you see all of the databases that we support as well. And let me just skip that last one. Just know we also have telemetry. Okay, these are all the databases we support today, and we'll likely be adding more databases soon. Let me not say database. We'll likely be adding data sources soon. That's because not everything is a database. Like, what if we wanted to go against Kusto or something like that? That'd be really neat, but it's not really a database, right? It's a data source. But nonetheless, these are all the things we have. This was my pause for questions. This is the halfway point, so I'm going to start talking fast. Yeah, thanks, Jason. I see you looking at your clock. That's great. Talking really fast, really, really fast. We support Key Vault to hold all of your secrets. You can either inject your environment variables into your containers or not, right? It's up to you, but now we have Key Vault support, which is the best way to have secrets. We have Inter support for authentication, which is probably the most important. We have NoSQL, which is very weird, right? We can infer from a sample query what the schema would have been from a NoSQL query, and then create a schema for you. That's important because you can't. Schemaless is the Wild West, and it's a mess. Like, it's a mess, and many of you are in that mess. Some of you are starting the mess, and just think it over. Okay. We support Redis for caching, which is super cool. Because everything is AI these days, we are also introducing a new embedding subsystem that allows you to pass us your string, and we give you back your vector, which is a big deal. From just a normal managed identity, this is what I was trying to explain earlier, where your token is passed, but it stops at the agent, and then the agent has a token, and then the API layer has a token as well. This is super common for applications, but not so much for agents. Now, in the agentic world, people are like, who's really doing this stuff? So we just pass the same token all the way through. So that's really important. And this talks about chain of custody and pooling. Just know we have thought this through. Like, it is an incredible tool. These are the 7 tools I was talking about. Create, read, update, delete. Execute is for store procedures, right? It's a little bit different operation, so you can't really do it the same. And then this final one is aggregate. We can do having clauses and group by clauses, so we can get big aggregates across your data. And so it's really nice to be able to do. Basically, we're handing it off to GraphQL to do it for us, which we've already built. So if you have a microservices world, that's it. This is an easy solution since it's free and tiny. So you could say, oh, I have these 3 databases. Each really needs to be a microservice so I can interact with it. You can absolutely do that just by adding in Data API Builder, and all of a sudden you have a POC by lunch, right? Which is a nice thing. And maybe it's lunch tomorrow, but nonetheless, you can have a quick POC. If it's not that you want, we can also change it so that you have backend as a service, which is more and more popular. And the reason you would do this is because it would matter to, let's say, this is your executive talking to your database. This is your normal user. This is your field user, office user, field user, executive. And you could be like, let's make this one nice and big so that the executive has an incredible experience, but we're not going to spend money on the regular plebes out there, so they have a terrible experience and hate their jobs. Okay. And as joking as that is, you know that's how it ends up going. You could also do CQRS, right, where I could take the exact same one and I could just turn off read access and I could just turn off write access. And now all of a sudden, if I set up a read-only replica, which is like 2 clicks in SQL Server these days, I have a second database that this one is pointing to, and then I have the actual production writable database that inside over here, but I can separate the calls so that I can make it so that my application feels faster and the database isn't loaded when I have really intense reads. Right? It's really nice. You're like, well, how am I going to do that with my API? You just copy Data API Builder. It's crazy straightforward. And let me just show you this just real quick, because it's a neat thing to show, is that, here we go. Oh, still not the right one. There we go. So now I'm inside the configuration file, and I don't remember what, I mean, this is character. Okay, so let me just show you. There's a section called permissions. Here's permission. And right now it says that the anonymous role can do anything, so star. But I could just come right here and make it so now it's read-only. So now anonymous can only read, right? And if I needed another, I would just add another. And they can continually just kind of go from there. And so if I needed to make it read-only, I mean, it's just so straightforward, so easy to do. I mean, it's just beautiful how whoever spec'd this, he was really knowing what he was doing. Okay, this is an example of like one could be bigger than the other, right? Because it totally makes sense. The deployment options are great. I don't know what you guys do when it comes to containers, but we support whatever it is, all of them. And we deliver from the MCR registry, the Microsoft Container Registry, which is the secure registry. That means we have to go through a security review, including things like the Mythos model attacks, every 3 weeks. And so we are constantly updating our container, even if we haven't changed the underlying code base. And we change the underlying code base and release every 2 months. And so unlike a normal open source project where you're like, oh, I wonder if the maintainer is alive. Now, we get pulled down if we're not compliant, which means if you use our container, it's as if you're using a Microsoft product just without a cost. It's really crazy. Okay, this is the command line to create dab init. This is the command line to create the initial file. It stubs it all out, does everything correctly with very, very little you need to change. In a normal scenario, nothing you need to change except for maybe mode from development to production. And then this is how I add one table, right? You would run this several times for every table. This defaults to anonymous as star, so you would think this through. You wouldn't just give everybody every access. By the way, the API doesn't override the API security doesn't override the security in the database. So if your database is already secure, and let's say it's read-only to us, and now I'm going to make my API read-write, and like, let's go at it. We don't override the database, of course, right? But that's a common misconception, and that's the reason I said it. And then dab start. No kidding, this is my typical demo, and it's a beautiful thing because it just, boom, everything right out of the gate, and I could do it in 3 lines. In the real world, right, you would add more than one table, and you'd add relationships because it's very useful, and you'd probably add descriptions now if you had an MCP. This runs for MCP and everything, so it's all ready to go. It's really nice. Let me show you this right here. So this is what, let me back up just for a second. Okay, yeah. So this is what the command line looks like when you run it. You kind of saw it when it was scrolling by. There's dab init, there's dab add customers. This is a video, so I can't really scroll into it, or zoom into it. But what I want you to see is I have this other of dab deploy, which is this is a prototype, so don't hold me to it, but it's going to be similar to this. And this video is real time. I have now sped it up. I know when you see it, you'll be like, I think you sped it up. It looks like you cut something. I really didn't. And when it runs, it is going to say deploy, and then it's going to say done, and then it's going to have a little thing that says, would you like to launch Visual Studio Code? The time in between that, so right now, we deploy a container. If you've ever deployed a container, you know it takes a minute or 3. So let's watch. I mean, you can already see the line is short. All right, so there's dab. They're about to hit enter. I just hit enter. It's now just deployed. So this new deployment scheme is unfreaking believable. And what we're trying to do is make it so that you can have MCP on the fly or REST on the fly as fast as you can do it. And it's a totally new technology. It's only inside of Azure. Just know that we preheat everything, and I mean it's really, really neat. And so we're hoping that maybe build time frame, which is next month, we'll be able to announce a public preview of this, being able to deploy a containered MCP as fast as you can breathe, basically. If I let this keep playing, I mean, you could see that there's a lot more to the video, but it's already deployed, right? The deploy thing, I mean, this is the deploy part. I wish we had a timer here. That would be so nice. And, but nonetheless, now if I said yes, which is what the video does, it launches Visual Studio Code and then installs the MCP so we can query it against the model. That is nice. So now I could actually tear it down and spin it up only when I know agents are active. I could use a hook inside of an agent to make it so that it activates an MCP that wasn't there originally. So really neat stuff that I can do. All right, so even though that's only a couple of seconds, I want to make sure not to go too long. Okay, so this is the Omnibus. This is the Omnibus VS Code extension. Pretty handy, to be honest. I use it in demos because it's so fast, but it's also very handy for you. All of the capabilities and a couple of extra things are built in, and I'll just show you, but not actually do it. That if I have a config, this is my dab JSON config file at the top left here, and so with that gigantic hand, I'm sure nobody has missed it. Right? Yeah, and so here are all the dab things, right? So I can add all the stored procedures, relationships, linking tables, auto entities, which we didn't even talk about. I can start it. I can validate it just to make sure I didn't introduce anything that's incompatible. Not just that it's valid, but also that it's right. So it goes to your database and double checks that all these things are real. I can visualize it, here I'll show you. It's kind of a cute one. Yeah, I mean, it visualizes it with a little mermaid diagram. It's very cool when you got dozens and dozens of things and then you lay them out. It's very hard to just scroll through a JSON file and figure out all of your objects. The health check, which you saw, right? Just a visualization of the health piece. Install MCP Server, right? If you select that, it jumps to this screen so I can install the running MCP Server that is running. It is not, oh, it is running. Here's what it looks like. Boop, now it's installed. And VS Code is sweet. I can't say how much they've done it for us. I can quickly put this into a Docker file and Docker up and Docker down. And so that's really handy. It'll build its own compose file for you if you select that. I won't do it, just trust me. And then generate C# will build out an entire solution based on the config file you have. And you're like, how do I even do this? Well, here, I'll just show you real quick. And so it's pretty fast, right? So I will use this connection string, and then you just kind of let it go. A gen folder shows up, and then I think there's a website and a console site and a library it creates for you, all with like 2 lines per class just to make it so that everything is laid out the way you'd want, but not so complex that it's annoying. And so it's pretty cool. It seems as if it's going to take a second. Just trust me, it's really neat. We'll come back to it. It'll be there. We won't come back to it. Who am I kidding? All right. We're natively supported inside of Aspire. So if you're using Aspire and you have the community toolkit, now you can say .add data API builder. Beautiful. Now we'll do everything for you behind the scenes. We'll create the container and all the connections for you as well. If you're not using Aspire, you should check that out. Pretty neat, life-changing, I will say. You gotta have containers. That's the only thing. I told you we were the backend. I don't know if I did say this. We're the backend engine behind the APIs in Microsoft Fabric. So we scale like crazy, which is terrific for us. And then finally, this is when I talk to people. These are all the points that I make that are the problems we try to solve. Things like APIs are coupled to schemas. Security is inconsistent across applications. Right? Expertise is required because you have to write T-SQL, or you need to know some sort of framework or ORM. And then we have all these beautiful things, like now we've completely eliminated non-deterministic T-SQL, which is probably the best part. And if nothing else, it is neat to think migrations are completely, imagine you were on-prem and you wanted to go to the cloud. You could swap it in your API and nobody would know the difference. And we would treat it the same and give you the same surface area. If you could even swap between Postgres and go to SQL, or go the other way. And you could keep a standard API surface, and all you have to do is change the connection string behind the scenes. Pretty cool. Right? And there's a lot that this gives you for free. And all of the capabilities that we have, paging and security and things like that, all across every database. Right? It's not like only SQL, and if you don't have SQL. There are some differences because not all databases are the same, but we do our best to keep everything in parity. And that's the end. Okay, so yeah, what I want to show you here is just that here we are. Here's our friends. They're one thing instead of two, but we show them as two. When you look at the entire suite of tooling around SQL, this is a major cornerstone piece that we're investing in heavily. And so I'll stop there and see if, actually, let me jump to this. These are the handy URLs. Really, really handy. If you're interested in Data API Builder at all, this is probably the best starting point. It'll just take you to our repository so you can see it. If you go to the top one, it'll take you to our docs, which are great. We're starting to change all of our docs to have AI prompts in them, which is hilarious. And this one might be the most interesting of all, akms/dab/meet, and it scheduled a meeting with me. And I'm glad to talk to you about it if it didn't make sense to you. So that's a dangerous thing to put up on the screen since this is being recorded and put on YouTube, but that's okay with me. All right, pretty cool. Thanks, everybody. That's SQL MCP Server. I'm glad you were here. Nice.